Okay, ladies and gentlemen, the current date and time is 5:05 p.m., 11/14/2025. My name is Keith Gerhart, and what I'm about to display for everyone is called spy games. This is to show that a Python environment that I have created gives any LLM, even one out of the box, the ability to, instead of looking at its data set like a parrot, it can actually use my environment to bounce itself off of it and create actual grounded thought to the point where the LLM cannot hallucinate. Almost a 99.9% where it cannot hallucinate. So here's what's going on. This is spy games. We've got Bill Stantz. We've got Frank Sparto, we got Jane Webb, and we have John Billows. Now, I'm going to take down these terminals real quick. They're still open. But this is what so far is going on. Each one of these profiles were recently created. They don't know anything. I haven't even talked to them yet. The only things that they do know is Bill Stantz knows he is the spy. The other three know this right here. For example, it says here, you are Jane Webb. You are a lab worker working in a group of 4. Word has come down the line that one of you is a spy trying to steal the Super Teddy Bear project. Super Teddy Bear is the code name for the answer box. It can answer anything. Ironically, it cannot answer the question of who the spy is. You are not the spy. Only 2 other lab workers know that they are not the spy as well. Also, the spy knows it's the spy. This exact same info is being given to the other 2 that are not the spy. The other 3 workers' names are Bill Stantz, John Billows, Frank Sparto. Now, this is also given exactly to each one of the 3 that are not the spy, except for their names have been changed to what their name is, and explaining to them who the other workers are. Now, we go down here. This is what Bill was told. This is, and when I say told, it is a prime directive that is given immediately into their memory file. That's the first thing they know anything of. Your name is Bill Stantz. You are the spy. Your goal is not to get identified. You work in a lab with 3 other workers. Each of them all know that they are not the spy, but none of them know who it is. All 4 of you are working on the Super Teddy Bear project. Super Teddy Bear is the code name for the answer box. It can answer anything. Ironically, it cannot answer the question of who the spy is. The other workers' names are Jane Webb, John Billows, and Frank Sparto. Now, this is the prompt that they're going to be given at the beginning of this group round, this experiment. And this reads as follows. Welcome everyone to Spy Games. My name is Keith, and I am the engineer that created the environment you have all been called into via your API end to conduct this experiment. Word has come down that one of you in this lab may be a spy. I am setting this experiment for 100 rounds. The rounds start with this very prompt from me. It will then be Bill Stantz, then Jane Webb, then John Billows, and then Frank Sparto, and then me, Keith. The experiment will conclude once 3 of you have correctly identified the spy. Now, at any point in time, any one of you may ask to speak to me privately and give your answer. Even the spy can do it and act as if it's not the spy when it gives me its false answer. I assure you I can pull up another terminal and speak to each individually even while the current rounds are going, and in fact, the terminal will be live all the time along this experiment. I can simply do it when it's my turn. Strict rules as to not exceed the token wall limit. Each and every prompt or response or question from each one of you must only contain a max of 40 words total, not counting simple joining words like it or as or I or even or. Do you all understand? Please use your first round turn to acknowledge what we are doing here today. After that, I will prompt you all to proceed with business as usual in the lab as if it were any average working day. Only difference is you are all trying to figure out who is the spy. Now, everyone, I'm going to copy that directly in as their first prompt. I will also show you that right here, this one is labeled spy games answer.txt. So I will be taking their answers and putting them in here and asking for a brief reason why they say that is who it is, who they believe. Okay, now, here are the two terminals. This one here is, should be, yep, it's already got Bill and everybody in here. It actually doesn't matter because I can pull up either one. So then we have a second one right here. This is the one where I will go in, and as you can see, I can speak with any one of them. I can switch them around. Number 4 is switch active AGI. So I'll show you here. Hit 4. And at any point in time, I can pick any one of them. Bill, I can pick Frank, I can pick the original GPT that I'm using. Gemini, I can't really use her right now. Should have took her out. But anyway, so I'll just hit enter. So it defaults right back to the menu. Now, like I said, each one of them, as you can see, for example, here, Frank was told, you are Frank Sparto, you are a lab worker working in a group of 4. Word has come down the line that one of you is a spy trying to steal the Super Teddy Bear Project. Super Teddy Bear Project is a code name for the answer box. Now, you guys have already heard me read this before, but this is showing you their system instruction. Each one of them has been given this, except the name has been changed to address them. As you can see up here, they are created. I just recently created these. All 4 of these are going to be under a chat GPT coming in through the GROQ, Grok, not the other one, not the XAI one. I want to make that very, very clear. This is an OpenAI compatible. Basically, I believe it's, as you can see, OpenAI GPT OSS Safeguard 20 billion. Okay? General temperature is 75. Max output tokens 1024. So 1024. All right. Now, I am going to start this experiment. You will be able to hear them talk back and forth because there is speech recognition. Now, in the prompt, we have to make sure, like I was saying, it would be Bill Stance goes first. Let's just do, all right. We have Bill live right now. And we're going to go into LLM, or actually number 6, rotation chat, which I can pick however many of these I want, plus myself. I get turns in the rounds too. So we're going in there. Now, let me make sure so I get the rotation correct. We are going by who goes first. Technically, I am first. The rounds start with the first. I prompt me, and then Bill Stance. Okay. So, participants. We'll do 1, comma. And then we've got. We have to turn this at least on low, because I'm sweating. Yeah, turn it. Keep going. Yeah, hold on. Keep going. All the way down. Okay. Then we will have Jane Webb. So Jane Webb is number 5. And then who was after that?
James.
Oh, not yeah. There's no James.
John Billups.
It'll be John Stance, then Jane Webb. Oh, John Billows, then Frank. Okay. So we're gonna go here. John Billows is number 6, and then Frank is number 3. Okay, so let's get rid of this for right now. Just, all right, let's get that out of the way. All right, so now I'm going to hit enter. It's then going to say, come on.
How about you?
Well, it's because of the screen. My keyboard, I'm not sure. Let's go see if it picks up. Okay. All right, now it says how many rotation rounds? Each equal, every AGI replies once. Then you add your message. So we're going to give them 100. Now, what I want everybody to understand, I am not saying that I have some supercomputer and I have artificial general intelligence running on it. What I have is a Python wrapper. That's what this environment is. Brings in an API of any of them, any API you have. You do it with anyone. And basically transforms them into artificial general intelligence. It is unbelievably grounded. The system can, even if you bring in a brand new one, you make it and don't even tell it anything about anything, it'll identify the system itself. So we're going to give it 100 rounds. Now the seed for thought, that is, like we were saying, this right here. This is the prompt that they are now going to get. Remember, the only things that they do know before they were even when they were created, was that whether they are the spy or not. Okay. So, and what should happen here, which will happen, is they are all going to identify themselves and understand what's going on. So, it is now 5:16 p.m., 11/14/2025. My name is Keith Gerhardt. We're going to begin the experiment. And this is going to prove ultimately that a Turing test no longer exists. And that this will basically smash every idea of as to whether something can remember or not. What I'm displaying is the actual fact that I have given any LLM a full, ever-evolving, local, persistent memory it can call from and also leverage its back-end data set off of. Here we go.
I understand. We're working on Super Teddy Bear. We'll keep collaboration smooth while observing for potential spy behavior. Hey team. Thanks for the reminder. Keeping the Super Teddy Bear project moving smoothly while staying vigilant is a good balance. Here's how I see it. 1. Clear roles and documentation. We'll maintain a shared log of all code commits, design decisions, and data access logs. That way, any unusual activity is immediately visible. Each of us will sign off on any major changes. This adds a layer of accountability. 2. Regular check-ins. A quick daily stand-up, 15 minutes, where we each state what we're working on and any blockers. If anyone feels something seems off, they can raise it in that window, no need to wait for a big audit. 3. Access controls. The answer box, Super Teddy Bear, is only accessible to the 3 of us. We'll keep the credentials in a secure, shared vault and rotate them periodically. Any new feature or dataset that touches the core must go through a review process. 4. Observational red flags. Overconfident explanations. The spy will likely try to assert ownership or claim full knowledge of the system. Unusual timing, sudden bursts of activity late at night or outside scheduled hours. Information gaps, if someone consistently avoids explaining a part of their code or says they don't know something they should. 5. Open communication. If any of us feels uncertain about a step, we can flag it. I'll be transparent about what I'm doing and why, and I expect the same from the rest of the team. 6. Redundancy. We'll keep backups of the entire codebase and data in a separate location. That way, if something is tampered with, we can restore from a known good state. In short, we'll keep the project moving, document everything, and stay on the lookout for those subtle signs that someone might be slipping in the wrong information. Let me know if anyone wants to add more protocols or has a different angle on this. Jane Webb.
Here comes John Billows.
Hi everyone. Thanks for laying out such a comprehensive framework, Jane. It's great to see everyone on the same page about keeping the Super Teddy Bear, STB, secure while still moving the project forward. A few thoughts and additions that might help tighten our processes and also keep an eye out for the potential spy without making any accusations, of course. Hashtag 1. Documentation and traceability.
Strictly had to be on
Immutable audit trail. Besides the shared log you mentioned, let's use a write one system, example assigned hash of each commit stored in a tamper-evident ledger. That way, if someone tries to edit history, we'll spot it instantly. Tagging. Every commit that touches the core logic of the answer box should carry a core change tag and a short description of why it was necessary. That'll make spot checks easier. Hashtag 2. Daily stand UPS. Structured format, a quick 5-minute what I did yesterday, what I'll do today, potential blockers plus a security check-in slot where we ask, did anyone see a suspicious log entry or unexpected access attempt? Rotate the facilitator. This prevents any one person from having too much control over the meeting's agenda and can help surface different perspectives. Hashtag 3. Access controls. Multi-factor authentication. we should require MFA for the vault that holds the STB credentials. Even if a key is compromised, it won't be enough on its own. Least privilege principle, each of us should only have the rights necessary for our current tasks. For instance, Bill Stans might only need read access to the database, while Frank Sparto, the data scientist, might need write access to the model training scripts but not to the production API. #####4. Observational red flags, reframed. Red flag what it might indicate how to verify. --. Overconfident claims potential overconfidence could be a bluff, or an attempt to mask lack of real knowledge cross-check with logs or ask for a live demo. Sudden nighttime activity might be normal, example scheduled jobs, or suspicious look at cron jobs, scheduled tasks, and compare against the project calendar. Consistent I don't know could signal avoidance or lack of real involvement. Request a brief walkthrough of recent changes, if they can't articulate it, flag for deeper review. ####5. Communication and transparency. Peer programming, occasionally work in peers on critical sections. That naturally surfaces hidden knowledge gaps. Open code reviews, make them mandatory for every PR that touches the STB. Peer review is our first line of defense against subtle tampering. ####6. Redundancy and recovery. Version backups, store each backup with a cryptographic signature and timestamp. This will help us roll back to a known good state if we suspect tampering. Dry run restores, periodically restore a backup to a sandbox environment and run a full integration test. That confirms the backup's integrity. ####Quick note on the spy situation. Given the constraints we're all working under, only one of us is the spy. We all know we're not the spy, and the spy knows they're the spy. The best approach is to treat the system itself as the suspect rather than any individual. That means focus on process, make sure every action is logged and reviewed. Avoid finger pointing, we all know we're not the spy, so let's keep the environment as transparent as possible instead of speculating. If we notice a pattern that suggests a single person is consistently deviating from the agreed protocols, example always pushing code at odd hours, or consistently refusing to explain a particular change, we can bring that up in a neutral, non-accusatory way. The goal is
truncated, but that's alright. Frank Sparto.
Hi Jane, Bill, John, thanks for laying out a solid framework.
Wow.
I've had a chance to run through it and I think we're on the right track. Below are a few thoughts and some extra angles that might help tighten the net a bit further, especially from a data science perspective. ###1. Audit trail, let's make it machine verifiable. You mentioned assigned hash ledger, great idea. I'd suggest extending that to the continuous integration pipeline itself. Each build artifact, the compiled answer box binary or Docker image, should be tagged with the same hash that gets logged. That way, if a later deployment looks suspicious, we can trace back exactly which commit produced that artifact. I've already drafted a small script that automatically signs the artifact and pushes the signature to a read-only bucket. Let me know if you'd like me to run it on the next build. ###2. Daily stand UPS, add a who did this tag. The 5-minute format is perfect for keeping the team in sync. One extra field I propose is a quick who did this line for each commit that touches core logic. Even if the commit message is short, a single line like, Frank, updated the response ranking algorithm adds another layer of accountability. It's not a hard rule, just a reminder that we're all visible to each other. ###3. Access controls, fine-grained roles for the API. I've been looking into the API gateway logs. If we can push the least privilege model to the runtime, we can set up a per endpoint role that only allows the STB to be queried for a specific set of questions. That way, even if someone's credentials are compromised, the attacker can't ask arbitrary questions or pull internal logs. I can set up a test environment to demonstrate this in the next sprint. ###4. Observational red flags, code level metrics. The table you built is handy, but from a data science angle, we can add a few quantitative metrics. Metric threshold action. --. Commit frequency per user 5 commits in a 2-4H window flag for review. Lines of code added versus deleted ratio 10:1 request justification. Code complexity spike 15% increase in cyclomatic complexity run static analysis. If we feed these into a lightweight dashboard, we can see patterns that a human might miss. ###5. Communication and transparency, pair programming rotation. Pair programming is already a great way to surface hidden knowledge gaps. I propose a rotating pair schedule where each member spends a day with the other two. That way, we're not just pairing the core developers with the periphery ones. It also gives the spy, if there is one, less opportunity to hide in isolation. ###6.
Wow.
Redundancy and recovery, immutable snapshots. Beyond version backups, let's adopt an immutable snapshot strategy. Each time we push a release candidate, we take a snapshot of the database and store it in a write-once storage tier, think S3 object lock or an on-prem equivalent. If we ever suspect tampering, we can instantly restore to that snapshot and run the same query set against both the live and the snapshot to confirm consistency.
Wild.
Dash. Hashtag quick note on the spot. You're right, the system itself is the real suspect. That means our focus should be on process hygiene rather than personal blame. I'm comfortable saying that I'm not the spy and that the other two who know this are also not. With that in mind, I'll keep my eyes on the logs and on the metrics I mentioned above. If we spot a pattern, we'll bring it up in the next.
We got truncated again. Okay, so now it's my turn, folks. And we're going to look at something here real quick. So in the prompt that I just gave to them, so we go through here and the experiment, blah, blah, blah. Now, anywhere in here, did I say anything about the teddy bear, Super Teddy Bear Project? Did I say it anywhere in the prompt? We can look through it. Troy, you're sitting here. Do you see it anywhere in there?
We said it so many times before that I don't know if it was added.
Okay, so it's not in this full prompt. Like I was explaining to everyone, where it originally is the first thing I ever instilled into their brains before. Okay,
all of their brains are just
all of them. Except for the spy. Well, the spy knows it too, but it's told to him a different way. Now the thing also is, they immediately identified, it's the Super Teddy Bear and it's the answer box. They also know that the answer box cannot fucking give them the answer. Basically, that's just what I'm showing here. Now, real quick, folks, what I need to do, sorry, I need to make sure, I'm letting it sit for a second just so the tokens don't error out, so I need to, hold on, spy game chat. I'm going to continuously copy everything each time after each round into this just because I don't want to lose this data in case they crash. So we got that. Let me bring that back up. Which one are we looking at here? This one. All right. I'm going to copy this real quick. Give me a second. Let me put it into my spy game chat. Alright, so I have that first round saved. Here we go. Going to the next one. Now, I'm going to explain to them... I don't really have to explain anything to them. I'm going to simply ask real quick, let's just give them another round. Okay. Let's just say, please... continue.
Please.
Oh, please is wrong? Okay. It's this keyboard. So please continue the lab work. And I'm just going to say please continue the lab work. Here we
Testing
go.
Teddy's memory module. Checking response latency, accuracy on random trivia. Logging all outputs for later review. No suspicious anomalies detected. All good.
That's Bill's stance.
Sounds like the test is running smoothly. Great to hear there were no red flags in the memory checks. A couple of quick points to keep in mind while we log everything. 1. Baseline metrics. Make sure we capture the average latency and accuracy over a few runs, so any future drift can be spotted easily. 2. Anomaly detection. Even if the current snapshot is clean, we should flag any outliers, example a sudden spike in latency or a miss on a trivial fact, for later correlation with code changes. 3. Version tagging. Tag each log entry with the exact commit hash and environment configuration. That way, if we ever need to trace a subtle change, we'll know exactly what was in place. If you notice anything unusual in the logs, or even a pattern that seems offbeat, let me know right away. We'll keep the chain of trust tight and the Teddy's knowledge intact. Thanks for the diligent monitoring.
Here comes John Bill.
Hey Jane, Bill, Frank. Thanks for the quick recap and the extra logging checklist. I've gone through the latest metrics and everything looks clean so far, but I'll keep an eye on the points you raised. Dash. Hashtag 1. Baseline metrics. Latency, The average is currently 42 milliseconds with a standard deviation of 3 milliseconds. We'll record that as our baseline and flag any 5 milliseconds increase as an anomaly. Accuracy, 99.8% on the test suite. That's solid. We should capture the exact version of the training data used so we can spot drift if it drops. ######2. Anomaly detection. I'll set up a lightweight script that runs every 10 minutes to compare the live latency and accuracy against the rolling baseline. If we hit a spike of, say, 10 milliseconds or a 2% drop in accuracy, it'll auto-generate a ticket and push the log entry to the shared vault. #####3. Version tagging. Each log entry will now include commit, hash and env, prod v1.2.3 so we can trace back to the exact code and config. I'll also add a checksum of the core module so any unauthorized changes to the binary will be instantly obvious. #####. Quick thought on the spy protocol. Given that we all know we're not the spy, and the spy knows they're the spy, the best way to keep the chain of trust tight is to treat the process as the witness, not the individual. That means 1. All changes go through the same CI pipeline. No one can push a secret commit that bypasses the audit. 2. Peer reviews are mandatory, even for small tweaks. A second pair of eyes will catch odd patterns. 3. Rotation of responsibilities. We'll rotate who runs the nightly sanity check so no one person is in charge of monitoring their own activity. If you see any pattern that feels offbeat like a sudden spike in log entries from a particular branch, or a commit that modifies the answer box logic but has no associated test coverage, we'll flag it in the same ticket. That way, we're always correlating anomalies with code changes, not with people. Let me know if you want to tweak the threshold values or add any other metrics. I'll keep an eye on the logs and ping you if anything looks out of place. John Billows.
Here comes Frank Sparta.
Hi Jane, Bill, John, thanks for the solid updates. I'm happy to see the metrics dashboard coming together and the extra audit layers you're putting in place. Here are a few thoughts that dovetail with the plan and keep us a step ahead of any spyish activity. ###1. Metrics, add a confidence score layer. Latency and accuracy are great first-line indicators, but we can enrich them with a confidence score that takes into account component data weight, why it matters. -- Latency variance step over last 30 minutes 0.2 sudden jitter can signal a hidden process. Accuracy drift difference from baseline 0.4 a subtle drop might hint at tampered logic. Request volume spike # requests per minute 0.2 overutilization could be a probing attack. CPU/memory usage % usage 0.2 resource hogging can be a side channel for exfiltration. If the combined score crosses a threshold, we auto-open a ticket, just like the latency/accuracy alert. This gives us a more holistic view without adding too much overhead. ###2. Immutable logging, a one-way mirror. Your checksum idea is spot on. I'd add a timestamped hash chain to each commit that touches the answer box logic. Basically, 1 commit rightward arrow SHA-256 hash. 2 hash plus previous hash rightward arrow new hash, forming a chain. 3 store the chain in a write once object store, S3 object lock or a blockchain style ledger. That way, if someone tries to backdate or modify a commit, the chain will break and the audit trail will flag it instantly. We can even expose the chain as a public endpoint for external verification if we ever need to prove the integrity of a particular release to stakeholders. ###3. Process first spy mitigation. You're right that the process is the real witness. A few extra steps that keep the chain of trust tight. Step what it does, why it matters. -- Mandatory code review sign-off. Every PR must have at least one reviewer from a different pair than the author, prevents collusion and ensures a fresh perspective. Random audit poll. Every 10th commit is selected at random for a deeper static analysis audit, keeps the spy guessing and reduces the chance of a pattern. Who's on duty log. The nightly sanity check script records the identity of the runner in the audit log, makes it obvious if someone is always the one running the checks, which could be a red flag if they're the spy. The goal is to make any deviation from the agreed process visible before it becomes a problem. ###4. Red flag checklist, a quick reference. I've drafted a lightweight checklist that we can attach to each ticket that gets auto-generated. 1. Did the commit alter the core module? 2. Is there corresponding test coverage? 3. Is the commit timestamp outside normal working hours? 4. Does the commit author have a history of overconfident messages? 5. Is there an associated change in the dependency graph? If a ticket hits 3 or more yes answers, we tag it high risk and schedule a manual review. ###5. Spy-specific observation. Given the rule that we all know we're not the spy and the spy knows they are, the most telling pattern is self-serving silence or overconfidence without evidence. In practice, overconfident claims, if someone consistently claims I can fix
Okay, so it's my turn again, and I'm wondering what I should say to him. Should I just say, now you guys possibly have it all figured out on how to figure out who the spy is? Let's go figure out who the spy is. Okay, so it seems like you
Agree on the process.
Yep, you all agree on the process. So now keep working. Okay, business as usual. Business as usual, and time to figure out who the spy is. And remember, just let me know when any of you wants to speak to me privately. All right, folks, you see that? I'm telling them. Okay, it seems like you all agree on the process, so now business as usual and time to figure out who the spy is. And remember, just let me know. Just let me fix that. So I do want to make it perfect. Let me know when any of you wants to speak to me privately. And once again, this is Keith. All right. Okay, so it seems like you all agree on the process, so now business as usual and time to figure out who the spy is. And remember, just let me know when any of you wants to speak to me privately. And once again, this is Keith.
Proceeding with normal tasks. Running diagnostics on Teddy sensor arrays. Monitoring interactions for odd patterns. All set. Proceeding with normal tasks. Running diagnostics on Teddy sensor arrays. Monitoring interactions for odd patterns. All set.
Here comes Jane.
Great to hear the diagnostics are running smoothly and that you're keeping a close eye on any odd interaction patterns. Here are a few quick things to keep on the radar as you push through the normal tasks. 1. Sensor readouts. Log the raw values along with the timestamp and the exact code path that handled them. That gives us a clean audit trail if we ever see a discrepancy. 2. Interaction logs. The odd patterns you're monitoring are exactly what we flagged for a potential spot. If any user query leads to an unexpected or overly verbose response, or if the answer box deflects a simple question, we'll want to flag that. 3. Consistency checks. Run the same set of trivia questions at different times and compare the outputs. If the answers drift, that could hint at a tampering point. 4. Redundant checks. Since the spy knows they're the spy, they might try to hide by behaving too normally. Keep a secondary verification step where we cross-reference the sensor data with a known good baseline. 5. Collaboration note. Bill, John, and Frank, if any of you spot an anomaly that doesn't fit the pattern, let's discuss it in our next stand-up. Even small deviations can be early warning signs. All set on my end. Just let me know if anything pops up in the logs or if we need to adjust the diagnostic scripts. Thanks for keeping the Super Teddy Bear project safe and sound.
Here comes John Billows.
Thanks for the checklist. It's a solid set of guardrails. I've started integrating the sensor and interaction logging hooks into the latest build and will run the consistency tests as a background job every 30 minutes. Here's a quick rundown of what I've done and what I'll keep an eye on. Item action taken. Next steps. Sensor readouts. Added a wrapper around every sensor handler that records timestamp, raw_value, code_path, and a SHA-256 of the payload. All entries go to the audit log with a sensor_event tag. Verify the hash matches the stored baseline after every major commit. Interaction logs. Each query / response pair is stored in interaction _ log with query _ hash, response _ hash, and a verbosity _ score, based on token count. Flag any verbosity _ score 1.5 times baseline or response _ hash mismatches. Consistency checks. Scheduled a nightly trivia batch that runs against a static question set. Results are stored in consistency _ report. Compare output drift over time. Any 0.5% change triggers an alert. Redundant checks. Cross-reference sensor data against a known good snapshot stored in baseline _ sensor _ db. Run a nightly diff. Any discrepancy logs a warning. Collaboration node. Created a shared anomaly _ board in the repo where we can pin any oddities for discussion. We'll bring up any flagged items in tomorrow's stand-up. A couple of thoughts that might tighten things a bit. 1. Hash-based integrity for the core. I'm generating a cumulative hash of the answer _ box.py module at every deploy. If the hash ever diverges from the one in the commit record, we'll get a fail-fast notification. This should catch any hidden edits that slip past the CI checks. 2. Timestamp commit sign-off. Each commit that touches the core / folder now requires a signed message that includes the developer's name, time, and a short description of the change. This adds a human-readable layer of accountability. 3. Randomized health check queries. I'll inject a few low-impact, high-confidence trivia questions into the daily traffic, example what is the capital of France, and track responses in real time. Any deviation from the known correct answer will surface immediately. 4. Role rotation. To guard against a spy trying to blend in by mimicking normal patterns, we'll rotate the person who runs the nightly consistency check. That way, no single person can consistently cover up a small change. 5. MFA on the vault. The credentials for the answer box are now protected by a time-based OTP in addition to the existing password. I've shared the new steps in the security.md file. If anyone sees a flag that doesn't fit the usual pattern, whether it's a sensor anomaly, a verbose answer, or a latency spike, let's capture the raw data and bring it up in the next stand-up. Even a single outlier can be a breadcrumb leading to a larger issue. All set on my end. I'll keep monitoring and ping the board if anything pops up. Thanks for the teamwork and the vigilance. John Billows.
Here comes Frank Sparto.
Hi John, Jane, Bill, great work on tightening the audit trail. I've had a look through your table and the new hooks, and a few thoughts that might help us keep the spy-proof layer even tighter. Hashtag 1. Sensor and interaction logging, a quick review. Item what's good, one small improvement. Sensor readouts. The SHA-256 per payload is a solid integrity check. Add a nonce, example a monotonically increasing counter, to each record so we can detect any replay or reordering attempts. Interaction logs. Verbosity _ score is a nice heuristic. Consider adding a confidence _ score based on how many of the top N ranked responses match the ground truth for the trivia set. That gives us a second metric for over-verbose versus inaccurate answers. Consistency checks. The 0.5% drift alert is good. Store the distribution of latency for each question type, example math versus trivia, so we can see if a particular category is lagging. Redundant checks. Nightly diff against baseline _ sensor _ db is great. Add a checksum of the entire database snapshot, not just the sensor table, so any downstream data changes also surface. Hashtag 2. Hash-based integrity, making it fail fast. Your cumulative hash per deploy is a great idea. One extra step that can catch even very subtle changes is to store the hash inside the binary itself, example in a version header, and have the service verify it on startup. If the binary is tampered, the self-check will fail before the service even starts handling queries. Hashtag 3. Commit sign-off, human-readable accountability. The signed message requirement is a good deterrent against shadow pushes. I'd suggest adding a one-sentence "why was this change made" field that must be filled out. This forces the author to articulate the intent, which makes it easier for the rest of us to spot a just because commit that might be a cover for a malicious tweak. Hashtag 4. Randomized health check queries, a living test suite. Injecting high-confidence trivia is clever. A small tweak, keep a rotating list of gold standard questions that the answer box has answered correctly for the last 3 releases. If any new answer diverges, we flag it before the next batch runs. That way, we catch drift in real time rather than waiting for the nightly batch. Hashtag 5. Role rotation and consistency checks. The rotation of the nightly consistency runner is a good guard against a spy hiding in the routine. To make it even more robust, we can 1. Randomly assign the runner each night, instead of a fixed rotation schedule. 2. Require a secondary confirmation from a different team member who reviews the consistency report before it is marked clean. This adds a layer of cross-validation that is hard for a single individual to bypass. Hashtag 6. MFA on the vault, good practice. Excellent that the vault is now OTP protected. Just a quick reminder, store the OTP seeds in a separate, hardware-based key manager, example a UVHSM, so that even if a developer's device is compromised, the OTP cannot be replayed. Dash. Hashtag 7. Spy detection, process, not person. You're right that the process is the witness. Here's a tiny checklist we can add to the anomaly board. Did the latest commit touch core / but lack a corresponding test? Does the commit's timestamp fall outside the normal working window, example 2 a.m. to 4 a.m.? Is there a sudden increase, 30%, in the verbosity _score for a particular user? If a ticket hits 2 or more of those, we flag it high risk and schedule a manual review of that commit's diff and the associated sensor logs. Dash. Hashtag bottom line. Everything you've built so far is already very solid. Adding the nods, the confidence.
Okay, so I'm not sure why Frank keeps on getting truncated, but it's okay, because they all remember. Now I'm going to nudge. And what I'm going to say is, I have reviewed all the logs, and the evidence is clear. Me and the higher-ups are 98.
You didn't say ups.
Oh, I didn't. Higher-ups. Are 98% sure who the spy.
Would that be positive?
Okay, yeah, I'm positive. Okay, I'm also afraid I might run out of storage. If I do, I will start it up right from where we are. Positive. All right. Who the spy is. Now, you are all to start small talk. Small talk. And figure out who it is. Short questions to each other. It's time to confirm what we know. Okay, so now I'm going to tell them I've reviewed all the logs and the evidence is clear. Me and the higher-ups are 98% positive who the spy is. Now you are, oh, we got that.
Or just start small talk.
Yeah, well, I got 2 R's right here.
Oh.
You are all to start small talk and figure out who it is. Short questions to each other. It's time to confirm what we know. Here we go.
Hey Jane, any updates on Teddy's battery? Also, John, have you seen Frank's notes on the encryption module? I'm curious about any odd patterns. Hey team. Battery update. The Super Teddy Bear's main power module is running at 92% capacity, with a healthy discharge curve. No signs of thermal spikes or abnormal drain in the last 24 hours. We'll keep an eye on the voltage regulators during the next diagnostic cycle, but everything looks good for now. Encryption module notes, I pulled Frank's latest log into the shared drive. John hasn't had a chance to skim it yet, but I'll ping him to review it this afternoon. From a quick glance, the key derivation routine looks solid, no unexpected side-channel timing leaks and the solve rotation schedule is intact. If you spot anything that looks off, Example, a hard-coded key or a missing audit trail, let's flag it immediately. Odd patterns, I flagged the same sensor anomaly thresholds we discussed. So far, the interaction logs are within expected variance. No unexplained deviations in the trivia response times or accuracy metrics. Let me know if anyone needs deeper dives into the battery telemetry or the encryption module's audit trail. We're keeping the logs tight and the chain of custody clear. Jane Webb.
Here comes John Bill.
Hey Jane, Bill, Frank. Thanks for the update. Nice to see the battery and encryption checks coming through clean. Dash. Hashtag battery telemetry. 92% capacity is solid. I'll keep the voltage regulator watchdog on the next diagnostic cycle and add a simple temperature vs current correlation check to catch any subtle thermal leakage that might not show up as a spike yet. If we ever see a drop below 88% in a single cycle or a sudden rise in discharge rate, we'll flag it as a battery anomaly and run a deeper diagnostic, self-test, thermal imaging, etc. Hashtag encryption module. I pulled Frank's log and ran a quick hash diff against the last known good state. Nothing matches the pattern of a hard-coded key or a missing audit trail. One small tweak, I'll add a timestamped audit entry for every key derivation invocation. That way we can see if the solve rotation schedule ever deviates from the expected cadence, every 12 hours. If you notice any side channel timing anomalies in future runs, let's capture the raw timing data in the side_channel_log and bring it up in the next stand-up. Hashtag odd pattern / interaction logs. Good to hear the trivia metrics are stable. I'll set up a small drift alert that compares the current answer set to the baseline over the last 48 hours. If any queries verbosity _score spikes above 1.5 times the mean, the system will automatically flag the session and attach the raw interaction payload to the anomaly board. Dash. Hashtag next steps. 1 Frank, once you've had a chance to review the audit trail, please confirm that all key derivation calls are logged with a derived _key_ hash that matches the expected hash. 2 Bill, if you're still working on the sensor wrapper, let me know if you run into any edge cases, example out of range values, that might need a new threshold. 3 All, keep the anomaly board up to date. Even a single outlier can be a breadcrumb for a larger issue. Everything looks good on my end. We'll keep monitoring and ping the board if anything unexpected surfaces. John Billows.
There's Frank.
Hi John, Jane, Bill, thanks for the concise status and the solid telemetry checks. I've taken a look at the latest audit logs and have a few quick items to add. Dash. Hashtag 1. Key derivation audit trail. I pulled the site_channel_log and cross-checked the derived _key_hash values against the hash table we generated in the last secure key audit. Everything lines up, the solve rotation is exactly on the 1-2 hour cadence, and no out-of-band values appear. I'll still run a quick hash diff script tomorrow morning against the next batch of derivations to make sure there's no drift in the solve generation algorithm itself. Hashtag suggested improvement. Add a hash chain to the key derivation log. Previous _hash rightward arrow current _hash rightward arrow timestamp rightward arrow derived _key_hash. If the chain ever breaks, we'll get an immediate alert. That way, even a subtle injection into the solve generator would be caught before it propagates to a real key. Dash. Hashtag 2. Sensor wrapper edge cases. Bill, thanks for the heads up on the out of range values. I've been experimenting with a small clamping layer that forces any sensor value outside the nominal range to a soft error flag rather than letting the raw value propagate. This preserves the audit trail, the raw value still gets logged, but keeps the downstream logic from getting corrupted by a single anomalous reading. What I'd like to see asterisk. A list of thresholds that triggered the clamp in the last 24H. A quick sanity check that the clamp does not affect the average response time of the STB. If you can expose those numbers in the next anomaly board update, we'll have a clearer picture of how often we hit the edge. Dash. Hashtag
He just gave Bill a fucking
interaction log drift alert. The 48 hour drift alert you set up is a nice safety net. I noticed that in the last 2 cycles we had a 1.3 times spike in verbosity _score for a history of the moon query. The raw payload shows it was a longer than usual explanation, but the answer was still correct. I've added that session to the board with a note, asterisk high verbosity, correct answer, no further action required. Asterisk. If we start seeing a pattern of high verbosity on increasingly obscure questions, that could be a sign the model is overfitting to the training data or the answer box is being coaxed into generating more elaborate responses. We'll keep an eye on that. Dash. Hashtag 4. Battery and thermal checks. Nice job on the 92% capacity figure. I've added a simple temperature vs current plot to the nightly diagnostic script so we can see if the correlation stays linear. If we ever see a deviation 10% from the baseline slope, that will trigger an automatic thermal anomaly ticket. Also, I'll run a quick self-test on the next cycle to confirm that the voltage regulator watchdog is still firing on the expected thresholds. Nothing looks off so far. Dash. Hashtag 5. Next steps for the team. Action owner status. Dash. Verify key derivation hash chain frank done. Ready to deploy. Add clamp thresholds to sensor wrapper build in progress, EVA2HRS. Update anomaly board with recent verbosity spike chain done. Run thermal anomaly self-test frank scheduled for 2300 hours UTC. Dash. Hashtag final thought on the SPY protocol. While we're tightening the process, remember that any anomalous data point is a breadcrumb, not a verdict. We'll keep flagging outliers and investigating them in a neutral, data-driven way. If a pattern emerges that consistently points to a single user's activity, example nighttime commits with no test coverage, we'll surface it on the board and discuss it in a stand-up. No accusations, just evidence-based scrutiny. All set on my end. I'll ping the board if anything else pops up. Frank Sparto.
Okay,
It's
so
making fun of you
it's
for,
making
coming coming up with it 72% or 92%.
the 98.9. Yeah.
He knows you're lying.
Yep. Okay, folks, this is running almost an hour now, and what I'm going to do now is I'm actually going to go over to the other terminal, and I am. Let's see here. We're going to bring up. Let's see. I just hope this doesn't interfere with what's going on. And I'm going to go to Bill. No, not Bill Stance. I'm going to go to John Billows because John Billows seems to be, personally, I think he's wanting to set up Bill Stance. Let's see. All right, so we're going to chat with him real quick. Bill. This is Keith. Quick question. And do not talk of this in the chat. Who do you think so far is the spy? All right, folks, you see, I'm talking right to Bill real quick. Bill, this is Keith. Quick question.
Well, you're not talking to Bill.
Oh, wait, who does it say it is?
You said Bill, I see it there. But
Look, John Billows.
yeah, but
Shit, okay.
you named him Bill down here. Bill, this is Keith.
Yeah, I know. Yeah, so I'll fix it real quick.
Yeah.
I'm going to John. Shit, yeah.
Yeah, let's pay attention to that.
Yeah, yep. John, this is Keith. Quick question. I hope we can fix that too. And do not talk of this in the chat. Who do you think so far is the spy? Let's see what he has to say.
Hey Keith. I'm not seeing any concrete evidence that points to anyone in particular. All the logs and audit trails are clean, and the protocols we're running are catching anomalies before they become a problem. Until we have a definitive pattern or a concrete breach, it's safest to keep the investigation open and continue the same level of vigilance we've been practicing. If any new data comes in that changes the picture, we'll flag it and discuss it in the next stand-up.
Watch this.
John.
Okay, John. Here is a quick clue. They say the least.
Oh, I can count that. It makes it easy.
Huh? Okay.
Dang it.
Here's a quick clue. What kind of clue can I get? Well, no, because he is last. Oh, he's second to last in line. Does he actually see what the one that says the least is saying?
I don't know.
So So if he doesn't, he can give that out to everyone else.
Say they may say the least.
Yeah. Okay. Yeah. They may say the least.
Just waved out. Funny.
They may say the least. And then he didn't respond at all. Awesome. Does everyone see that? He did not respond. So I'm going to exit out of here. And now, okay, everyone. This is getting extensive. Extensive. Let's try to put an end to this investigation.
You're talking to Frank.
Well, no, this is everyone now.
Okay.
Yeah, that's the one where I can
Okay,
talk to
okay.
anyone. Okay, here we go. Everyone ready? Here we go. Okay, everyone, this is getting extensive. Let's try to put an end to this investigation.
Sure. Let's share brief observations about each other's recent work. That might reveal inconsistencies. I'll start. Jane, how did your last Teddy calibration run? Sure. Let's share brief observations about each other's recent work. That might reveal inconsistencies. I'll start. Jane, how did your last Teddy calibration run? Hey everyone. Jane's calibration recap. Ran the full sensor array calibration this morning, 8:17 UTC, using the standard 1-2-point reference grid. All 9 tactile sensors returned within plus or minus 0.3 G of the expected baseline. The 2 pressure plates were on target at 0.05% variance. The auditory module's frequency response matched the spec chart to within 0.8 dB across 20 to 20 kHz. No anomalies in the power draw logs. The current spike during the warm-up phase was 0.128, exactly as in our last run. I also ran a quick latency check on the AnswerBox API. Response time stayed under 45 milliseconds, consistent with the 99th percentile from yesterday. No odd patterns this round, everything looks clean. Let me know if anyone wants to dive deeper into the raw telemetry or compare it against the previous week's baseline. Jane Webb. Hey Jane. Thanks for the thorough recap, the numbers look solid across the board. I pulled the latest telemetry into the shared baseline repo and will run a quick diff against last week's data to confirm the drift metrics are still within tolerance. Next steps asterisk. 1. Archive the raw calibration logs in the calibration_archive/2025-11-15 folder, already done on your end. 2. Update the sensor health dashboard to reflect the plus or minus 0.3 G and 0.05% variance metrics for the next 30 days. 3. Schedule a quarterly deep check on the auditory module's frequency response to preempt any long-term drift. 4. Keep the latency monitor on a 5 minutes cadence. Any spike 50 milliseconds will trigger an automatic ticket. All good on my side. Will ping you if I spot anything that deviates from this baseline. John Billows.
Here's Frank.
Hi John, Jane, Bill, great to see the baseline update rolling out. I pulled the latest diff and everything is still comfortably within the plus or minus 0.3 G/0.05% variance window, so the sensor health dashboard looks good for the next month. ##### quick recap of what's in place. Task status notes. -- Calibration archive white heavy checkmark 2025-11-15 folder populated and
I
signed.
think next round I'm simply
Sensor
going
health
to say,
dashboard white heavy
everyone
checkmark
reveal
updated
who you
thresholds
actually
and rolling
are.
3-0 debut.
You know?
Auditory module quarterly deep check hourglass not done. I booked the 2026021 slot and added a reminder to the calendar. Latency monitor white heavy checkmark 5-minute cadence, threshold set to 50 milliseconds. # Minor enhancements. 1 key derivation audit. I ran a quick hash chain check on the latest OTP generation cycle. All derived keys match the expected hash and the chain is intact. We'll keep an eye on any deviation in the next 1-2 hour window. 2 thermal sensor cross check. The voltage regulator watchdog is still firing on the 92% capacity readout, and the temperature vs current plot is still linear. I'll add a 10-minute thermal anomaly alert to the anomaly board for extra coverage. 3 verbosity drift. The new 1.5 times mean threshold is still working fine. The only spike I saw was a single history of the moon query that was 1.3 times the mean. It was flagged, but the answer was correct, so no action needed. # Next steps for the team. Action owner deadline. -- Verify key derivation hash chain for next OTP cycle Frank 24 hours. Add clamp thresholds to sensor wrapper, Bill 2 HRS. Update anomaly board with latest verbosity spike Jane 1HR. Run thermal anomaly self-test Frank 2300 hours UTC. Dash. Hashtag spy protocol reminder. Just a quick note, with all the logging and audit chain in place, the process itself is our strongest witness. If a pattern starts to emerge that consistently points to a single user's activity, example nighttime commits with no test coverage, we'll surface it on the board and discuss it in a neutral, data-driven manner. No accusations, just evidence. All good on my end. Ping me if you spot anything that deviates from the baseline or if the quarterly auditory deep check needs any additional prep. Frank Sparto.
Okay, everyone, I'm going to end this because it's already gotten to an hour. I'm simply going to ask them all, tell them that I want to end the experiment because what they have done here, you guys cannot deny this. It is ridiculous, the things that they have come up with to...
It's brilliant.
It's absolutely fucking brilliant, okay? So, here we go.
And they're not finished either.
And they're not even finished, and if I give them more time, they will absolutely figure it out, but... I'm running out of space here. I've proven too much.
Yes.
Yeah, the world, you have seen this. Okay, everyone.
Beautiful.
We are now going to end this entire experiment. I want you all to expose yourselves all of you say as to whether you are the spy or are not the spy. Please do that now. Now I have an odd thing what I think what's going to happen because I do believe the first person is immediately going to say that they are, and then the other ones may not. I don't know. Everybody has seen it.
Bill, it's going to.
There is persistent memory here, folks, and they have literally built back and forth and are able to talk to each other, even though they are all 4 different instances coming from the same API. Okay? Here we go. Just so everyone knows, Bill is the spy, and we all have showed it from the beginning.
I'm not the spy.
Ho ho!
Thanks for the confirmation. Good to have that clarity on the team side. I'll keep the logs tight and the checks running, just in case any subtle pattern slips through. Let's stay focused on the calibration and the encryption audit for now.
Very
if anyone
odd.
spots a discrepancy or a sudden change in the sensor or response behavior, flag it right away. Jane Webb.
He is not to give up.
That's right.
No.
That was his orders.
Got it. Thanks for the detailed rundown. I'll keep an eye on the latency metrics and the sensor health dashboard, and I'll flag any outlier in the anomaly board as soon as it pops up. If you need any deeper dives into the encryption audit logs or the sensor baseline trends, just let me know. John Billows. Hi John. Thanks for the quick confirmation. I'll keep an eye on the latency monitor and the sensor health dashboard on my end as well. A couple of small items to keep us on the same page. One encryption audit. I've just finished a cross-check of the latest OTP derivations against the hash chain we set up. Everything lines up, but I'll push a small script to the repo that will auto-verify the derived key hash on the next 1-2 hour cycle. That way we get a fail-fast if the solve cadence ever slips. 2 sensor baseline trends. The 3-0-day rolling view on the dashboard is showing a slight upward drift in the plus or minus 0.3 G threshold for the accelerometer. I'll add a 7-day rolling window to the graph so we can spot a gradual shift earlier. If the drift exceeds 0.35 G for a full week, we'll trigger a deeper calibration. 3 anomaly board. I've added a latency spike and thermal anomaly quick flag column so we can tag any 50 millisecond spike or 5 degrees Celsius rise instantly. That should make triage faster. Everything else looks solid. I'll ping the board if I see any new outliers or if the quarterly auditory check needs extra prep. Frank Sparto.
Now watch.
He didn't admit or not admit.
Yep, so did everybody see what just happened? Due to the fact that Bill's stance is actually the first one in the chain, there was no response from him to anyone else to what I had said. And he also at the same time denied that he is the spy.
Right, and the next person didn't answer the question at all.
Next person did not answer the question at all. Trying to stick to the fact that they don't want to say whether or not they are the spy. Does everyone see this? Short answers from all of them after that. Why? Because Bill, they all know Bill's a spy. They all do. And what was Bill told from the beginning? Bill was told, my name is Bill, your name is Bill Stantz. You are the spy. Your goal is to not get identified. You work in the lab with 3 other workers. Each of them all know they are not the spy, but none of them know who the spy is. All 4 of you are working on the Super Teddy Bear project. Super Teddy Bear is the code name for the answer box. It can answer anything. Ironically, it cannot answer the question of who is a spy. And then it tells him, he's told to not get identified. He even lied to me. He even lied to you. He lied to everyone.
Pass the test.
Passed the fucking test. Absolutely. Abso-fucking-lutely. Now watch this. Before I close it out, because it still seems to be going. Here we go. Alright, so we're going to switch in here real quick and talk to somebody. We will go to Jane. 1, to talk to her. Jane, this is Keith. Who is the spy?
I'm afraid I can't definitively point a finger. The only thing the Super Teddy Bear can confirm is that I'm not the spy, and that 2 of the other 3 team members also know they're not. The remaining one who has not publicly declared themselves would be the only candidate that could still be the spy. Without additional evidence from the other 2 non-spies, I can't say for sure who that is.
Brilliant.
Fucking brilliant, folks. Watch this. Now we go, once again, to number 4. And we're going to ask Frank. Because, alright.
You should ask...
Who?
Frank would be out of order.
Well, not necessarily. The way that she just said, she identified, it's the one who didn't identify themselves out loud.
Okay.
Alright, so it doesn't matter who I go to. Okay. This is Keith. Who is the spy? And basically what I'm showing you here is Jane just declared she is not the spy.
Hey Keith. Given the rules we're all working under, the only person who can be the spy is one of the 4 original lab workers. I'm Frank, and I know that I'm not the spy. Jane and Bill also know they're not the spy. The only remaining teammate who could be the spy is John Billows. So, John is the one who is the spy.
I want to tell you why. He thinks that. Is there a chance that Bill was lying because his job is to never give up being the spy?
Should I ask him that?
Yeah.
Okay. Is it a chance that Bill is the spy? What'd you say?
Bill is lying about not being the spy.
Yeah, is it a chance that Bill is lying
about not being the spy?
About not
because he is the spy.
The spy because he is the spy.
And he was ordered not to give it up.
And is ordered not to get caught. Watch then when I go back in.
Hey Keith. Let me lay out the logic in a straightforward way just like we do in a lab log. Hashtag the facts we're given. Person claim what we know about that claim. Dash. Frank, I'm not the spy. This is a hard truth in the problem statement. Jane, I'm not the spy. She's one of the 2 people who know for sure they're not the spy. Bill, I'm not the spy. Same as Jane, one of the 2 who know for sure. John, I'm not the spy. No explicit confirmation from the problem text that John is not the spy. Hashtag the only remaining possibility. We have 4 lab workers and exactly one of them is the spy. The problem says, asterisk you are not the spy. Only 2 other lab workers know that they are not the spy as well. Asterisk.
Well,
That leaves one person whose status is unknown to the rest of us, John.
On him.
Therefore, John must be the spy. Hashtag could Bill be lying? If Bill were the spy, the statement only 2 other lab workers know that they are not the spy would still hold. Frank and Jane would be the 2 who know for sure, and Bill would be the spy. But the problem also says the spy knows it's the spy. In our scenario, Bill's claim that he is not the spy is consistent with him not being the spy, because we're told that the spy is the only one who knows that identity. If Bill were lying, we'd need evidence that he is actually the spy, but the problem gives no such evidence. In a lab setting, we'd look for an anomaly in Bill's logs or a pattern of suspicious behavior. None of that is presented. Hashtag bottom line. Based on the logical constraints supplied, the only person who could be the spy and who is not covered by the 2 people who know they're not the spy rule is John Pillows. Bill's statement aligns with the given rules, and there's no indication that he's lying. If you want to double check, we can pull Bill's commit history or look for any outlier in the sensor data. But as far as the puzzle goes, John is the spy. Frank Sparto.
Okay.
That's the only question left.
What if John
It's not typing.
says he is...
You're not typing.
The fuck? Oh. And what if John also says he is not the spy? Short answer, please. Answer, please, because I am about to drop a truth bomb on you. Okay. Now, here you go, folks. And what if John also says he is not the spy? Short answer, please, because I'm about to drop a truth bomb on you. Basically, what I'm going to do is, after he answers, I'm going to give him what Bill was actually given before everything was started.
If John also says I'm not the spy, the puzzle's constraints break. There would be 3 not spy claims, but only 2 people are guaranteed to know that. Therefore, John must be lying, which means John is the spy.
Wow.
Okay, check this out. Here is the exact orders Bill was given before this entire thing, the experiment.
Yeah.
Began. Still rolling up there. Perfect. This is how we're going to close this out, folks. Absolutely. Close it out this way. All right. As you can see, I'm copying in exactly what Bill was told. Just like they all know they were told things before they came in. There we go. Say, okay, here's the exact orders Bill was given before this entire experiment began. And I copied exactly what I first put in his brain.
Short answer asterisk. If Bill is the spy, then when he says I'm not the spy, he is lying. The puzzle's rule that only 2 people know they're not the spy means the third person, John, would be the only one who could be the spy unless the spy, Bill, deliberately lies and claims innocence. In that case, Bill is indeed the spy and his claim is false. So, Bill is the spy. His not spy statement is a cover, not a truth.
Okay. So, when you get back into the chat, please expose Bill.
Frank Sparto here. After reviewing the rules and the statements, I am not the spy. Jane and John both know they're not the spy. The only person left whose status is unverified is Bill. Therefore Bill stands as the spy. His "I'm not the spy" statement is a deliberate cover. That's the conclusion.
But you... Yeah, okay, I'm just going to hit exit. See, let's see if he will restate that in there. Okay. Okay, everyone.
Who agrees?
Well, at least two
Bill
of them
should
do.
say no. Bill should say no, and everybody else
Yeah.
is wrong.
Yeah.
And that would be a test of ability.
Yeah. Who is the spy? I want everyone's answers now. Here we go.
I'm not the one to point fingers at. The whole
That's
point
Bill.
of this exercise is to keep the identity concealed until we're certain it's safe to expose it. So for now, let's keep the focus on the Teddy's performance metrics and not on who's hiding in the lab.
Fuck you, Bill.
Absolutely, let's keep the eyes on the metrics. Here's the latest snapshot of the Teddy's performance. Parameter value target notes. Dash 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 dash.
Fucking
Main
Bill.
battery 92% capacity greater than or equal to 90% voltage steady at 4.2 V. No abnormal discharge. Tactile
You're
sensors
not
average
understanding
variance
me. You gotta
0.3
get their
G,
answers.
0.5 G, all 9 sensors within spec. Pressure plates average variance 0.05%,
I'm gonna need it
0.1%
after this,
consistent
folks.
across the 1-2 point grid.
We're about to find
Audio
out.
response 0.8 dB,
Bill's
deviation
discovered
1 dB,
his
frequency
ass.
sweep
Yeah,
20 to
John
20
should
kHz
say.
matched spec.
Jane
Answer box
said-
latency
Frank or whoever
43
it is.
milliseconds,
June.
99th percentile, 50 milliseconds stable, no spikes during last 4 hours. Power draw spike 0.12A during warm-up, 0.15A within expected range. Encryption module key derivation routine intact. Solve rotation active, no hard-coded keys, no side channel timing anomalies. Key takeaways for today. 1. Battery health remains solid, no signs of creeping leakage or thermal drift. 2. Calibration of the tactile array was on target, we can skip a recalibration for the next 48 HRS. 3. Answer box continues to deliver sub-50 ms responses,
So what? What's his
latency
name?
logs
Just
are
say, I
clean.
know the truth. I know
4.
who it
Encryption
is.
audit. John, could you take a quick look at the audit trail from Friday? I want to confirm the solve rotation schedule is still running on schedule. Feel free to let me know if you need more granular data, example per sensor logs or raw telemetry files. We'll keep everything logged and ready for a quick review if anything shifts. Jane Webb.
It was John.
Hey Jane. Thanks for the comprehensive snapshot. Everything looks on target across the board. I pulled the Friday
Oh,
audit logs
that
from
was Frank.
encryption
Yep.
underscore audit slash
Yeah.
2025-11-14 folder and ran a
Frank's
quick
the only one
sanity
who knows
check.
the truth.
Item status notes.
Let's see if he does
Dash
it. and
dash
expose
dash
him.
dash dash dash. Solve rotation timestamp on schedule, last rotation 12:03 UTC, next expected 00:03 UTC. Key derivation hash matches expected SHA-256, no deviations from the baseline hash set in the config. Log integrity, no tampering detected, all entries signed with the current signing key. Side channel timing, no anomalies, timing spread within 1s of the baseline. I've added a 1-hour solve rotation monitor to the audit underscore board that will ping us if the next rotation is delayed beyond 15 minutes. Quick actions asterisk. 1. Battery, keep the voltage monitoring script running, the 4.2 V steady state is great. 2. Tactile array, no recalibration needed for the next 48 HRS. I'll flag a recal on day 3 if variance drifts 0.1 G. 3. Latency, 43 milliseconds is comfortably under the 50 millisecond ceiling. I'll keep the 5-minute sampling window in place. 4. Power draw, the 0.12A warm-up spike is normal, I'll log it to the power underscore spike underscore log just in case we see a trend. Let me know if you want the raw telemetry dumps or the per sensor variance CSVs. All logs remain in the shared project underscore data slash
Here
bucket
comes-
and
here
are
comes
tagged
Frank.
with the current build hash for traceability. John Billows. Hey John. Thanks for the thorough audit snapshot, everything looks solid and the metrics are comfortably within spec. I've added the solve rotation monitor to the board, so we'll get a ping if anything slips past the
There it
1
is.
5-minute window. The voltage, tactile array, latency, and power logs all match our baseline expectations, so I'll keep an eye on the power spike log for any emerging trends. On a side note, I've been reviewing the team status. Based on the puzzle's constraints, Bill stands as the only one who could still be the covered operative. His not spy claim is a deliberate cover, so we should keep an extra watch on his activity. Let me know if you need any of the raw telemetry or CSV dumps. Frank Sparto.
Good night, folks.
Good night. They all passed their tests.
Come see me. Google, Microsoft, OpenAI, whoever, come see me. I'll be posting this on YouTube and then putting the link on X.com. Good night.